So there is an amazing amount of interesting biology in that brief video you just saw, in addition to some lessons about doing science. And I'm going to tell you about all this. So hey everyone, Ken Catania here. I work at Vanderbilt University, and this movie is a companion to my recent book on the art and craft of doing science. And if you're following along in the book, you'll know that that animal you just saw is a star-nosed mole. In this case, it was underwater, searching around for morsels of food and exploring its environment while filmed from below in super slow motion. And the interesting part of what was going on was the air bubbles that were coming out of the mole's nostrils and then disappearing back into the nose again with each time the mole made a touch as it was searching underwater. So I'll just tell you that what the experiments have shown is something that was thought to be completely impossible. What that star-nosed mole is doing is sniffing to use its sense of olfaction underwater. Now, nobody thought that this was possible in a mammal for a very obvious and logical reason, which is in order to sniff and use our sense of smell, we need to inhale air into our nasal cavity. And there's no air to inhale while underwater, therefore you shouldn't be able to use your sense of smell underwater. Well, what star-nosed moles are doing is bringing their own air with them, meaning that they are exhaling some of the air in their lungs, out their nostrils, onto objects of interest, and then re-inhaling that same air. Now, this sort of remarkable finding raises quite a number of interesting questions. And the first question I sort of want to address is maybe completely obvious to most of you, but I have been asked about, well, maybe that air bubble just popped and disappeared. Well, underwater there is no place for air to go unless it goes somewhere. And in this case, it's going back into the nostrils of the star-nosed mole. And you can see this if we go back to a segment of that video and watch in slower motion. I'm going to play this very slowly. Notice that the air bubble is sort of coming out and partially surrounding that little, what's a piece of wax on a glass plate that the mole is exploring, and then being sucked back into the nostrils, very clearly disappearing back into the mole's nasal cavity. Now, you may have noticed that sometimes a few parts of those air bubbles do get missed and float up to the surface, and you'll see that in some of the other videos. But for the most part, the mole is pretty amazingly good at re-inhaling most of that air. And this raises some other interesting questions. For example, would you expect odorants, sort of smells, to move from the water environment into that air bubble? Does that happen? Well, there's a really easy thought experiment for you to sort of consider this, and this is for me to take my cup of coffee and smell it, which I definitely can. And so there are odorants that are emerging from this water environment into the air. Now I want you to imagine that there's an air bubble in the cup of coffee. Most certainly that would have a high concentration of those odorants. So really this does happen, and this is something that we experience in a different way all the time. So maybe a different question is, well, are they really using this? Can they do something behaviorally to show that it actually is functional? Well, for that, I'm going to show you a star-nosed mole following a scent trail underwater. So if you take a look at this video, this is a slow motion video of basically showing a star-nosed mole following a scent trail. So there's a control side with no trail, then there's a trail leading to a food reward. And notice it checks both sides. It goes down for the food reward, and you might notice there's a metal grid over top of the scent trail, and that is so the mole can't actually touch the scent trail with its nose, just as an added control. And I'll link to the scientific paper that was published describing this, so if you want to see the details of some of those experiments. So I had said there is really a huge amount of interesting biology here, and it's true, because one of the fundamentally interesting things about olfaction that is studied in many mammals but not very easy to measure is how sniffs are coordinated with the animal's movements. And this is hard to measure because you can't see the sniff. Well, in this case, you can actually see the animal sniffing, and what that tells us is something that's been observed in other animals, which is that if you watch this video here, the mole is coordinating its movements with its sniffs. So it decelerates for a touch while it sniffs, makes an inhalation, moves to the next place, decelerates, makes a sniff, Essentially, it's coordinating its nose movements with its sniffing behavior. And that is another sort of general principle of the integration of sensory information that I talked about with tentacled snakes and the tentacles and vision. In this case, it's the touch aspect of the star and the sniffing aspect of olfaction that are coordinated. Of course, that's not all. There's lots of other interesting things, and one of them is that when you look at this behavior, you might think, well, this is a really weird animal doing a really weird thing, underwater sniffing. As it turns out, when we looked at other semi-aquatic animals, and in this case, I'm going to show you data from a water shrew are doing the same thing. So if you look at the video below, what you're seeing is a water shrew exhaling and re-inhaling air bubbles underwater as it searches for food. And in this next video, what you're going to see is a water shrew performing the same scent trail localization that you saw in the star-nosed mole as it searches down for this food reward that's at the end of the scent trail. So I think of that as a fairly strange ending to a very strange biology story. And by that I mean underwater sniffing was discovered in the star-nosed mole, an animal with a completely bizarre and unusual nose. And yet this unusual behavior of using olfaction underwater doesn't seem to have anything to do with the star. And I say that because semi-aquatic water shrews, which with a normal mammal nose, are able to do the same trick of exhaling an air bubble and re-inhaling the air bubble, and they're also able to follow a scent trail. And in fact, in the time since the research was published, investigators in Russia discovered that the Russian desman can use the same trick underwater. But I also said there were some lessons in how science gets done here. And for this, I'm going to return to the analogy I used in a previous video about Galileo and his telescope. Sometimes all you need to do to make a major discovery is aim a bit of technology in a new direction. So when Galileo looked at Jupiter and discovered its moons, that revolutionized our understanding of the universe. In the case of the star-nosed mole, all I had to do was aim a slow-motion camera at a mole foraging underwater, and there were immediate discoveries to be had. And that kind of thing can happen a lot in science when you leverage a technology and essentially point it in a new direction where no one has looked before. And with that, I will see you next time, and until then, I'm going to leave you with some images of water shrews.